So, hello everyone. Welcome to the workshop. I'm Bhumika and I will be the host for today. I'm also one of the new co-organizers of PyLadies Amsterdam, and I'm really happy to be here. And this is my first time doing this, so yeah, good luck to me and good luck to Saskia. So, this workshop is about introduction to natural language processing, and I will hand over the floor to Saskia for the workshop. Before that, a quick introduction to PyLadies Amsterdam. We are a community that believes in two main things: bridging the gender gap in technology, mostly in Python, and secondly, in creating better coders and developers in Python. So, with that in mind, we want to have a lot of workshops and have a hands-on approach where we have practical coding and yeah, we give people experience not through theory, but through code. So that's our main mission. And today's workshop is aimed towards NLP, and Saskia will lead us today. Before we start that, three basic ground rules. Um, Everyone is muted by default. This is to avoid any disturbance to this workshop. If you have questions during the workshop, please type them out in the chat. Me and Aliona will be monitoring the chat. And if it's something that is stopping the flow of the workshop, then we will ask it immediately. Otherwise, we will wait until the Q&A session or until there's a break for an exercise. During the exercise period, we have a few exercises in between. So if you have a question then, you can raise your hand and we will allow you to unmute yourself and ask your question. We also have a dedicated Q&A session towards the end if time permits, so you can also ask questions then. Besides that, the collab notebook that we have, we request you to create a local copy of it and save it with your name. This is to avoid any interference to the workshop because collab is not the best at syncing multiple people, and we don't want to interrupt the workshop that way. So with that in mind, Saskia, the floor is all yours. Go ahead.
Thank you. Well, first of all, Aliona and Bhumika, thank you so much for inviting me. Really feels like an honor to be here. I really like the mission that PyLadies has to make coding available and accessible to everybody, and then especially trying to promote it among everybody, and then make sure that there's a lot more women represented in tech, especially in the Netherlands. So there's few of us. It's still very underrepresented, and I think that's a shame. So I really like the initiative to promote this a bit better. Today I'll be talking about NLP, or natural language processing. I hope nobody's here to get a neuro-linguistic programming course, because that's a completely different field, but I hope you're all in here for some natural language processing. But before I start with just a short set of slides and the workshop itself, I wanted to share with you a Mentimeter, because I'm just curious what you've been doing, how much experience you have with NLP, just to get a grasp and an idea of where you're all at. And let me share my screen. And by the way, if you cannot hear me properly, or if there's any other question, please do use the chat. I like to keep this as interactive as possible. So there you go. Let's see. Now I should be able to share.
Yes.
So there we go. There's a Mentimeter. For people that are not familiar with it, just go to a browser, take in menti.com, and then you can fill in the code that's here on the top side of the screen, the 3A33012. And then you'll see the same question that's asked here, and you can actually react. And whenever all of you are doing this, we can get a nice interactive overview of where you're at. So just curious about how much experience you have with NLP. Already have 9 reactions. That's going quite well. Very nice. How many people are in the workshop in total? To know
Right
where.
now we have 28. That's including us, so 23. Sorry, 25.
25. So we'll wait a little bit until everybody has responded, or at least most of you. But I'm already seeing a pattern here. Most of you are completely new to the topic of NLP. So there will be a lot of new things for you today. It might be the case that some things are going a bit too fast. If that is the case, please interrupt me. Please ask a question in the chat. We're all here to learn. And it would be wonderful if you can take something out of this course and immediately start doing and applying this tomorrow. I see there's some people that have some limited experience and who've been playing around with some code, so you might recognize some of the things I'll introduce today. Some people have already been using NLP in some project works or will be able to do so. So hopefully I'll be able to give you some extra hints, some extra code and ideas today. And there's somebody who's used NLP a lot and is also a bit familiar with some deep learning techniques. Today we won't touch upon any deep learning. There will be a slight mention of it and a very small section in the code where you can actually apply one of the main deep learning architectures, transformers, to code, to NLP problems, so just to get a gist of it. So let's go to the next question. Okay, this is not working. Let me stop sharing because the Mentimeter is crashing on me right now. But thank you, that was really nice. Let's see if I can somehow stop this. There we go. Let me share again. I'm sorry, I'm a bit rusty when it comes to Zoom. I think in times of Corona, we're all using different systems, and we're mostly working in teams, you know. And I'm also curious about your current role. So what is the job that you're working at? Or are you a student, or maybe a PhD candidate, or a postdoc or researcher? That's interesting. We have a lot of other categories. So I would be curious if you could maybe share in a chat, if you want, what your job role is currently, because I'd be curious to know. I thought that we probably have a lot of data scientists hanging in today, but there's a lot of others in the session. So I'm very curious to hear from you what you're working on. So I'm going to close up the voting. I'm going to stop sharing the Mentimeter. I see there's somebody working as a software developer, a project manager, and media analysis. So that's super interesting. Data analysis, business developer with IT knowledge. Oh, that's a very interesting role also. And it's also really useful for us developers to be working with people that actually know what's behind the code and then have a deeper knowledge of it. So it's really cool you're here. Business intelligence ETL developer, nice. Banking sector, oh, cool. Looking for a job in the Netherlands, that would be really cool if you could find something. So nice, it's nice to hear from you. Oh, let's see. Let me share the screen of the presentation so we can get started. So there we go, it should be in presentation mode.
It's not in presentation mode yet.
Wait, I did this before when we were practicing. Let's see, this should work now. If I share it right now, you should be able to see the presentation. Can you see it,
Yes.
Bhumika?
Yeah.
Perfect. So there we go. Introduction to NLP. I prepared a couple of slides just to get a quick overview. First of all, who am I? Why am I giving this workshop? Why NLP? Then I just wanted to give you a brief overview of all the different subfields that are within NLP. So what can you do with it? What are typical use cases? What types of things do you do when you are working in NLP? And then we get to work. We get our hands on some hands-on coding. And just as Bhumika said, it won't be a very theoretical session. It's more hands-on. If you're really interested about the theories and the algorithms behind the NLP, please contact me. Feel free to email me or contact me on LinkedIn. And of course, internet is also full of very nice blog posts. YouTube is a great resource. So this is me. I started my interest in languages when I was a very small girl. Was already very fond of different languages and languages in general. So that's why I studied linguistics at Leiden University and continued finishing a PhD degree there. Was in experimental and computational linguistics. So I was mostly studying how people study different combinations of words in the brain. And along the way, I discovered that in order to do so, and in order to interpret all this data, you need a little bit more than just Excel. It could be really useful to know a bit about machine learning, a bit about programming, and that's how I slowly rolled into it. After the PhD, I spent some time at the Huygens Institute to work on some computational stylistics. So basically finding quantitative ways to say or to explain why something is considered as literature or not. That was really interesting. After that, I joined CGI, which is an IT consultancy firm, and worked there as a data scientist for a while. And a couple of months ago, actually at the start of the Corona crisis, I started I started my job at TNO, also as a data scientist with a specific focus on NLP and text mining. And I work there at the data science unit, and I'm mostly working in the security and security domain. Yeah, as I said, I've always been fascinated by language, and I think it's really cool that we can somehow grasp this very ungraspable, very fluid, amazing, creative, emotional thing that's language, that is full of irregularities and can still somehow translate some of it into a computer and into numbers so that we can start to compute with it. That's a fascinating field for me. And besides that, I love to talk. Of course, as a linguist and as an NLP researcher, it's nice if you also like your words. I love eating. I just finished my dinner. Sorry for Bhumika and Aljoja, they could also see me eating. I love to cook. Reading is also a big hobby of mine. Dancing, salsa, crazy about it right now. It's a bit... I stopped doing it for a while because of Corona, but I also really like to keep my mind off work for a while and then dance the night away, so to speak. So just to get an overview of what NLP is more or less. So oftentimes you hear this term artificial intelligence, deep learning, machine learning, and also linguistics. I'm a linguist myself. And basically NLP is somehow at the cross-section of all these fields. So it could be considered as a part of linguistics, and oftentimes it's called computational linguistics. It's also considered a part of artificial intelligence. And then again, within NLP, we make use of some machine learning algorithms. Deep learning right now is becoming a big part of NLP, and it has caused a lot of very exciting developments over the past few years. And NLP itself is also divided up in several subfields. So there you see NLG and NLU, and I'll get back to that, what that means. So basically there's a very big subdivision you can make. You can either focus on text or on speech. And if you look at NLP for text, then there's a subdivision you can make between natural language generation, where you have a language model that generates text for you. You have natural language processing, and you have natural language understanding. And the idea is that after you've processed and parsed and then kind of analyzed parts of the text, you can go a step further and actually start to reason over the language and basically let the computer understand it, quote unquote, what it's reading. Yeah, as for natural language generation, you might have heard of GPT-3. That's a recent, a very powerful model that was able to even write newspaper articles. It wrote an article in The Guardian where it said that we don't have to worry about computers taking over humanity. It's a really interesting article. You should read it. It's also able to generate code for you. So very exciting developments there. As for natural language processing, if you look at the names, there's named entity recognition. That's something we're going to do in a workshop today. And basically it means is that you use a computer to automatically extract person names, place names, organizations, etc. out of a text. We're also going to do some part of speech tagging. So remember in high school when you had to, or even in primary school, you had to do these exercises and then say which parts of the sentence is the subject and which is the direct object, etc. You can have the computer do that for you. There's a lot of interesting techniques behind it, but here we're just going to get some hands-on experience with it. Like how can you get it out of a text by using Python? And also some syntactic parsing. We'll also look into that. I call it dependency parsing. Machine translation. We're all familiar with Google Translate. That's also a big field within NLP. And then if you go a step further into natural language understanding, yeah, basically I think entity or information extraction is a big field right now. It's becoming more and more important in different use cases, that you're able to extract relevant information from text without having to go through the text yourself. So if you're interested, for example, to know a bit more about recent developments concerning, for example, COVID, it's really interesting if you can extract that information automatically. And also summarization is becoming big. Then another part that we're not going to touch at all today is the natural language for speech. That's a whole different field. It's also sometimes referred to as automatic speech recognition, but also speech generation is actually part of this field. And there's a lot of very exciting developments going on there. So if you're into speech, you're up for a treat. So some common use cases of NLP. So of course the translations, it's also in use nowadays to detect fake news, classifying emails. We're all familiar with the spam detectors that we have. If you go to the right hand side, there you see, for example, sentiment analysis. So you can say whether or not the message has a positive or a negative emotion connected to it. Personal voice assistant, Siri, for example, there's a lot of NLP techniques behind that. So one thing we're going to touch upon today is this big issue. You can imagine there's text, there's a computer, and somehow this computer manages to start to extract information from text and apply machine learning algorithms to it. How do you do that? Because you cannot compute over words. You cannot compute the sum of king and queen, for example. So people have used different techniques to go from a text to a set of digits with which you can calculate and compute things. So bag of words, that's a very old technique where people just made a huge word list of maybe 10,000 words and then started to count how often each word occurred in every single document or sentence. And basically what you get then is a big table with a lot of zeros, because most words don't occur all at once in the same sentence, and some numbers that tell you which words do occur. And then later on, people discovered that it's probably better to also take into account how the words are distributed over the text. So you can imagine if you just count the frequency of a word, so how often it occurs, then words like the and it and she and he, they start to appear a lot in your feature list. And those are not the words that are most relevant. So TF-IDF, it's called, term frequency, inverse document frequency, also looks at how spread out a word is over a set of documents. And if it occurs very frequently, but also in all documents that you have, then probably it won't carry a lot of information. It doesn't really stand out. It's not very discriminative for a certain label or category of text. But if it has a very high occurrence, but only in a small subset of texts, then hey, it might be an interesting word. So imagine the word elephant popping up very frequently, but only in a small subset of texts. That might be a set of text that's concerned with zoos or something like that. But even more recently, people started working with word embeddings. You might have come across this term. What are they? They're also a numerical representation of text. But with word embeddings, why they are so useful and popular nowadays is that they do a bit more than encode how often a word occurs and how it's distributed across your text. It also kind of encodes what the word means. So that's very interesting. What people do, they learn a neural network on a huge amount of text. And this model, they give the task, so to say, to predict if you have one word, for example, the word fish, in what type of context does it occur? So does fish occur in the context of cat? Does it occur in the context of water, etc.? Then you learn a neural network to predict that. Or turn it around, you have all these contexts. Does a word occur in a certain context? You can learn this model. There's a lot of very interesting blog posts online that explain this a bit better to you. But from this model, you can extract one of the hidden layers. And this hidden layer is a list of numbers, and that encodes more or less the context of a word and therefore also its meaning. And there's this guy, might be familiar with him. Firth, he was a corpus linguist, and he said, you know what a word means by the context, by the neighbors it keeps, the context it keeps. You can imagine the word dog occurs a lot in the context of barking and walking outside, whereas a fish might occur more in the context of water and swimming and sea. So by just looking at how a word relates to its context, you get to know what the word means more or less. So it's a very powerful idea. I'll also dive into word embeddings a bit during the workshop. So just wanted to very shortly touch upon the newest developments that we see within NLP. So traditionally, we have a lot of text. We perform a lot of NLP steps or pre-processing steps to this text. We extract a lot of features out of it. We do a lot of feature engineering. Then we start to apply machine learning models. And then we can use these machine learning models to predict, for example, the label of a text or the sentiment of a text. However, nowadays we see a big shift towards end-to-end machine learning models. And this basically means you don't have to tinker with the data yourself. You just throw in a bunch of data, simply said, give it to the model. Model starts to do its thing. And then at the end of it, almost magically, appears the prediction that you need for a sentiment model or a classification or things like that. And these end-to-end models have been very popular for a couple of years already, especially computer vision. They were big, but starting in 2017, basically, but also a bit earlier, it also became a big topic in NLP. So once you start to go a bit deeper in NLP, you will see that there's a lot of deep learning around. And one of the most powerful mechanisms that make this possible is called attention. Attention is all you need. It's one of the famous papers if you want to read it. And it's basically a mechanism that tells a machine learning model which words it should pay attention to, literally, for it to perform well. That's just a very simple explanation, but the transformer architecture, so there was a deep learning architecture that has a certain amount, a certain, how do you say, order of steps, a certain order of architectures. That's called the transformer model that uses attention. And these are two terms that you're going to see a lot when you dive into deep learning and NLP. Transformers is part of the Hugging Face library. So if you're interested, definitely go to their website. They have a great API. They have a lot of tutorials, also linked to a lot of blog posts. There's a lot of things available online, also on YouTube. Keep these terms in mind if you're diving deeper into NLP. And of course, BERT. you're cool in NLP if you use a Sesame Street character as the name for your language model. So BERT was basically a huge step forward. All the state-of-the-art benchmarks have been shattered by using a transformer model in a specific way, and they call this a BERT model. Very impressive results, and right now the developments are going faster and faster and faster. Right now there's also a big bird, Pino in Dutch, another Sesame Street character that's getting even better results. And anyway, so keep your eyes out for these topics, just as a small teaser. So let's start the code. Let's get some hands-on experience. I think the link was already shared, but I'll make sure to also share it with you in the chats in just a moment. And make sure that you save the file under your own name. I'll just show you in a minute how to do that, so that we don't start to work on the same called up notebook at the same time, get syncing issues, etc. And also there's my email address. So if you have any questions, feel free to reach out to me. While I set up the Colab notebook, I'm going to stop sharing here so I can see the questions if there's any questions. So if there's no questions, then I'll start sharing my Colab screen. Okay, you will see it.
Yes, we can see your screen. Could you increase the font size a bit though?
Mm-hmm. Is this better?
Your screen changed. You're at your desk now, I think.
Yep, I'll make it bigger like this.
Slightly bigger, maybe?
Yeah, it's getting there. It's reacting a bit slowly.
There's always a bit of lag on calls, so.
So if anybody has some hints on how to zoom besides scrolling and Control+. Let's see if there's any zoom in here. How's the resolution now?
It's much better, but it's a little hard to read still, so.
Yeah, let me try something else. I'll bring it onto my to my other screen, and then I'll share again. Let's see if that does the trick.
You can, oh yeah, this is better.
Yeah, this is better? Okay, cool. So there we go. And as you can see here on the top hand side, I saved this notebook with the underscore and then my own name behind the file name. And you can just go to file. It's my Colab is in Dutch. And then you can just say save. And then you make sure that you have your own local copy. If something goes wrong, just raise your hand. Let me know. Bhumika, please interrupt me if there's any urgent questions or any questions at all. The dog is also coming in. So yeah, the first thing that we're going to do, we're going to read in some Python libraries that will help us with the NLP tasks. And as you can see here on the left-hand side, there's a couple of them that I selected for today. So we're going to analyze some texts, and we're going to split it into sentences, split text into words. So you'll see it's not as easy as you might suspect. We'll tag words. So we'll give it a label if it's a noun or a verb. We will parse sentences, so you will get an idea of how different parts of the sentence relate to each other. And we'll extract named entities, so person names, geopolitical entities, organizations. So that's the first thing that we're going to do with the text. And after that, we're going to prepare text for machine learning. So we're going to load a data set. We're going to pre-process it. So what are the typical steps that you take before you can feed a text into a machine learning model? So most of you will also want to know how to use NLP for language modeling, for machine learning. And then we'll train a machine learning model and see how well it does. We'll predict some unseen data. And in the end, I'll show you quickly how to use one of these fancy deep learning models that I briefly mentioned at the end, and how you can actually use it if you don't have any labeled data, but you do have labels or things that you want to assign to the texts, and how you can leverage this deep learning power to do something that we call zero-shot classification. We'll get to that in the end. So first of all, is there anybody having trouble with opening the notebook? If so, please let us know, and I'll be sharing my screen, so hopefully you'll be able to still follow along. So
we have one no in the chat, so I'm guessing everyone's good to go.
Okay, perfect. Sounds good. So this Colab notebook is very nice for a couple of reasons. First of all, it's very easy to run Python in here, and I'm not just doing an NLP workshop in Python because it's a PyLadies event, also because Python is I would say the default almost if you want to do something with NLP tooling. Some people use R. There's probably some functionalities available in other languages, but still the main bulk and the big developments are made available in Python, and it's quite easy to use. So if you click on this little arrow here, the cell will start to run, and it will start to load.
Saskia, we have a question about whether this can be run locally, and is it better to run it online as compared to locally?
Let's do it online for now. You can run it locally, that's fine. But then you'll have to skip one or two parts of the notebook. And why? I wanted to also show you a little bit of these deep learning models of the transformers that I mentioned briefly. And one of the things with deep learning is that it needs a lot of computing power, and especially even inferencing. So if you have a trained model based on a deep learning architecture and you want to use it to predict new data, it's called inferencing. Some people call it like that. You will need a lot of computing power, and typically if you run it over a CPU, it will be extremely slow. If you run it over a GPU or TPU, it gets a lot faster. And within Google Colab, it's really nice. You can actually say that you want to run it over a GPU or TPU, and depending on the availability, you get some very powerful computing power that can run the cell for you. So that's one of the big advantages that I see for the Google Colab, especially if you're working with NLP. You go a bit further into the field, you'll be crying if there's no GPUs available for you. So it's good to get a gist of how it works, but feel free to follow along locally, and if some process takes too much time, you can just kill it. But yeah, we'll start with some simple huis, tuin en keuken, as we say in Dutch, house, garden, and kitchen tooling. That doesn't need any fancy GPU computing power at the moment. We'll import something that's called NLTK, or Natural Language Toolkit. That has a lot of natural language processing functionalities in it. Pandas, because I like to work from data frames. And Pandas is the library for that. I'm importing Ray, or regex, regular expressions. It's very useful, especially if you're working with text data. Sometimes you just need to extract a specific pattern, and then a simple regex can sometimes be your biggest friend. So it's really worth the time to spend some time in learning how to use regex. No, it's definitely a nice thing to have in your toolkit when working with text data. We're also going to import a data set from scikit-learn. Scikit-learn is a very famous library for all its machine learning algorithms and easy to use infrastructure. The 20 News group data set is very famous. So you'll often see it in blog posts when people try out different machine learning algorithms. They oftentimes use the 20 News group data set. I'm sorry. spaCy. That's also a very famous library, and you will see it's super easy to use, and it has a lot of functionalities in there. And even now, even though there's a lot of fancy techniques out there, I oftentimes notice that when I'm in a project and I need to build something quick, or they're expecting at least some first benchmarking results, with spaCy you can get some really nice results in a short amount of time because it's already grown-up library, so to say. There's a lot of developers that's been working on it extensively. It's an amazing tool, and it's really my first go-to when I start to model something up. TQDUM. This is a library that allows you to print a progress bar, so you can see how far along in the process you are. I'm downloading some stuff from NLTK. Oftentimes when you use NLTK, it might throw you an error saying that it misses the punkt data set or the tag set data set. So here I'm already downloading it, so we won't have any trouble later on. And here I'm initializing a TQDM progress bar that is specifically used within Pandas data frame. So if you run some operations on Pandas. So enough for me. Let's get to work. I'll briefly explain to you what you're going to do in the next 5 minutes, and then it might be nice for you to try out some coding yourself. And really, like, one of the very first things that you often do when you get some texts is that you start to explore it, and you need to break it up into separate sentences and separate words. We call this sentence tokenization or word tokenization. I think NLTK is a perfect tool for that. It has different methods in it. It has a word tokenize method. It has a sentence tokenize method. But before using this library, it's always a good idea to try to split a text into sentences yourself and to see in what kind of troubles you might run if you try to do that. So there's a task here, and here's some texts. And try to split up this text in different sentences, seeing what kind of trouble you run if you try to do it, or maybe you don't run into any trouble. And there's different paragraphs that you can use. Here, you just have to put in some code. Here's some hints about what type of code you could use. And if this is really easy for you, then try to do this advanced exercise. If you're done very quickly, then please offer your help in the chat to the other PyLadies. So let's code up. You get 5 minutes. 14 past, we'll get back together, but try to see if you can split up the sentences in, or split up the paragraphs into separate sentences. I'm gonna stop sharing so I can see the chats. In the meantime, I'm just gonna get a glass of water before I start coughing again. There's a very good question from Linda. Why I prefer NLTK over spaCy to split up sentences, and I'll get back to that in a moment, Linda. It's an excellent question. Just a short answer is it's oftentimes faster because spaCy takes up a lot of computing time sometimes, but we'll show that in a minute. Yeah, Hilda, I see your question. Very good points. That's, of course, I did that on purpose. There's words like Mr. that end in a period. That makes it harder to split the sentences. Now go to the, yep, for the reasons that Hilda mentioned. Yeah, there you can see it's 14 past. Let me share my screen again and show you what happens. So basically, if you just want to split a paragraph into its different sentences, then I think most of you thought about splitting up the sentences using a period as a splitter. So basically what you get then, if you run this cell, so you split the paragraph, and here's this paragraph. I don't know if anybody recognized it, but it's from Sherlock Holmes. If you split it by this period, then you see that indeed it nicely splits the different sentences and makes it into an array with this list of sentences. But then indeed, as some of you already remarked, when you try this same trick with paragraph number 2, then indeed you get some unwanted behavior, because Mr. Here ends in a period. But of course, it's not a period that signals the end of a sentence. It's just a period that signals an abbreviation. So there you run into the problem that it splits the sentence somewhere halfway. And number 3 is even worse. So if you have paragraph number 3 and then split it up using a period. Oh, excuse me. There you can see that here, for example, there's this alias Whitney, DD, and then of course it will split it into D, D, and then principal, Saint, George, etc., etc. So it's not working so well, and I don't know if you can come up with some solutions. One of them, which is actually behind most of the sentence tokenizers, is that you have a language-specific sentence tokenizer, which takes into account common abbreviations. So here in English, for example, this abbreviation of Mr. period and Saint, which is abbreviated as ST period, that's included in a list of frequent abbreviations. And these abbreviations are then used as a way to signal to the tokenizer, to the sentence tokenizer, that they should not be taken into account when you split up the sentences. They're kind of a list of exceptions, so you will. Now, if you were to build that yourself, it will take you some time. You have to compile a list of frequent abbreviations, of exceptions, make sure that those are not taken into account when you start to split up the sentences. So this is why it's so nice to just use a library that does that for you. So NLTK, the default comes with an English language model. If you start to look into the documentation of NLTK, you will see that there's different language models available. So in Dutch, for example, there's also some abbreviations or some exceptions that use a period without signaling the end of a sentence. So you can see here the send tokenize method. You just say NLTK.send tokenized, and then you feed it the text, the string that you want to have tokenized, and it will do it for you. And then we just look into the first, so this is the 0, the first sentence that the tokenizer will take for you, will create for you. And here you see that it indeed nicely ignores this Mr. And if you look at the third paragraph, which was kind of a challenge, I would say, you see it's doing it really nicely. The DD indeed is recognized not as the end of a sentence, but as a real, let me move my head over here, but it's really recognized as an abbreviation. The same with Saint George. So that's really nice. And I got the question in the chat, why use NLTK to do this for you, and why not do this with spaCy? We'll get into spaCy a bit later, but what I really like about NLTK is that it's fast. It will split up the sentences quite fast for you, whereas if you use spaCy to split up the sentences, if you use the default settings of spaCy, it will split up the sentences. It will start to part of speech tag all of the words. It will start to calculate how the words are related to each other. It will extract named entities for you. It will get word embeddings for you. It will, so in other words, if you create a spaCy object, it will automatically perform a lot of NLP tasks. It will do a lot of analysis on your sentence. This is not a problem if you just have maybe 10 sentences or 100. But once you have texts of 1,000 sentences or even more, and using these spaCy methods can really slow down your process. Whereas with NLTK, this goes blazingly fast. So it's mostly a matter of timing. But indeed, you can also use spaCy to tokenize your sentences. But we'll get to that. So for me, the main reason to use NLTK is because it's just fast. And also quite short to code. If you do want to use spaCy just for tokenizing, and if you don't want spaCy to do all the other NLP tasks, you can tell spaCy to ignore certain operations, do not perform certain operations, but then you will have to actually write that down. Makes your code a bit longer. It's not so easy to read anymore. So this is basically why I prefer NLTK. I hope this answers your question. Yeah, so we split up the text into sentences, and we can also split it up into words, because in the end, you want to have words out of your sentences. And again, if we just do it with split and tell it to split everything based on a space, And then again, there's always exceptions and problems that you run into. It's actually 2 words, not 1 word. That you're joining this workshop. Your is also seen as 1 word, also not optimal. Again, you could code it up yourself, define a whole list of exceptions based on the language that you're using. But with NLTK, the default setting is English in this case. It immediately understands that this from its is actually a separate word, namely the verb. And again, it recognizes here also that this is a separate word. So that's a really nice functionality of NLTK. Now let's move on to the next set of functions, tag. So as I have written here, sometimes it's useful for you to only extract nouns from a text. Or maybe you just want to extract all combinations of an adjective and a noun. So maybe you want to know which verbs combine with the word NLP. Especially in information extraction, it can sometimes be very useful if you define certain patterns, syntactic patterns, so you will from a text. So maybe you're interested in knowing what entities or what nouns are combined with the word fighting to kind of extract from a text who doesn't like each other, who's fighting with each other. And that is very useful if you can actually get nouns plus the verb they belong to plus their direct or indirect objects. And this grammatical analysis, we call it part of speech tagging. So for every part of speech, we assign a label. So NLTK has a built-in tagger that can do that for you. This is just to show you that NLTK can also do this. In practice, I always use spaCy for this. But just to show you how it works, it's relatively easy. You define a sentence. In this case, it's great that you're joining this workshop. There's a raised hand, Simona. I'm sorry, I cannot see the chats. Maybe somebody can read out her chats or unmute Simona.
Simona, maybe you can put your question in the chat and then.
Now I can see the chats. Let's see, let me first answer this question. Why do you have a 0 at the end of NLTK send tokenize? Let me just get back to that piece of code. So basically what I did here, I took a subset of the full output that you get. And let's just take this first paragraph that you have here. So we're tokenizing this paragraph into separate sentences. And what it then does, what you get as an output is a list of the different sentences. And you can see here that it's a list because of those square brackets. And every item in the list and every item in this array is 1 line, and then there's a comma. So there's basically a list of different elements. And if I want to access or get only the first sentence or the first item of this list, I can use the 0 as a subset or as a way to access this very first part of the list. So if I run this, then you will see that as an output I will only get in the year of 1878, etc. There you go. And if I do a 1, I'll get the second sentence out, etc. So it's, for me, it was just an easy way to only show you the relevant sentence where this Mr. and Saint, etc. took place. Yes, Bhumika was already answering that. Thank you. So the same you can also do if you split up the words. For example, you can also access the first element of a word by running this, for example. It will give you it. And you can even make it shorter. Maybe say, for example, I want to tokenize this sentence. So split it up into different words and then take the first to the third word out of it. Then we can print the words. And also, if you're after this workshop, if you want to play around with the code, feel free to do so. And if you're afraid to mess up, don't be. You can always save for yourself another copy, name it version experiment or something, and really start to play around with the code. Try to see what the zeros, etc., do, because that's in the end the best way to learn how to use the code, how to start coding in Python. Is just really by experimenting and trying to understand what each and every part does. So after splitting up your paragraph into sentences and words, you can perform some more analysis on it. And here we're using NLTK to assign a syntactic label to the different words. So here, first of all, before doing anything, I'm splitting up a sentence into its separate words, because a part of speech tagger oftentimes of NLTK expects a list of words. So it wants to have a tokenized sentence. And I just say, okay, NLTK, use your method's POS tag, so post of speech, part of speech tagging. And then it will give you a list of tuples. We call this tuples, where you have the word. And then behind the word, we have some abbreviations, PRP, VVZ, JJ, etc. Those are abbreviations of parts of speech. For example, this JJ stands for as an adjective. Those are words like great or red or blue or beautiful. And if you want to know a bit more about what all these abbreviations stand for, then this is the helper function that lists nicely all these abbreviations with their explanations. Let me check the chat again. Yeah, which languages does NLTK support? I don't know from the top of my head, but there's at least a couple of dozen that it supports. Dutch, absolutely, because when I got a course in NLP, we used a lot of Dutch sentences. I think Spanish, Portuguese, several Slavic languages are supported, but it's good to always check the documentation. We didn't tell NLTK that we're processing English. Does it detect it by itself? As far as I know, NLTK's default language is English. So if I will feed it something in Dutch, it will probably not recognize it unless something has changed in the library over time. There is, however, a very useful language detection library that you can use, Detect. And Detect can detect for you which language is used. It's not foolproof, but oftentimes it works reasonably well. Yeah, it's just the default language. So there we go, and here you see all these abbreviations. But enough of NLTK. Let's dive into spaCy. Yeah, so these NLTK taggers, they're working quite well. Yeah, we look into this this sentence. We see that it's nicely assigning different parts of speech to our words. But in practice, most people nowadays would use the spaCy library to do that for you. And I also often default to spaCy to do these kinds of tasks, because spaCy has this very nice library with a lot of functionalities. It's a very grown-up, a mature library with a huge community, an amazing website with a lot of great tutorials. Would definitely check it out. So if you're interested in knowing more about spaCy and getting a bit more practice, do go to their website, spacy.io. They have some great materials there also. So what spaCy will do, oh, let me run this cell. So with just a very few lines of code, a very simple way of coding, spaCy will automatically tokenize a sentence for you, or tokenize a whole paragraph for you. It will take out the different words. It will assign parts of speech tags for you. it will perform something that we call dependency parsing. So that's basically the language model will figure out which nouns belong to which adjectives, which verbs belong to which direct objects, for example. It will lemmatize your sentences. We'll get to that, what that means. Oh, I shouldn't double click on the text. And it can also perform named entity recognition for you. And the only things that you have to do is basically just 3 steps. First of all, you read in a language model that is able to process your text. And within the spaCy website, you can see a whole list of different languages that have different language models. For English, for example, there's 3 different language models that you can use, each with their own pros and cons. So some language models are bigger than others or have different functionalities. And what you can do with this language model, we create an object, a language model object, which is oftentimes called NLP. So here you can see it. So we create something that's called NLP by using the spaCy.load and then the ncore SM. That's one of the English language models that spaCy offers. Once you do that, you can use this NLP language model to create something that's called a doc object, a document object, and oftentimes that's called doc. So this is just the basic syntax and names that you often see. So you have NLP, you create a doc using this NLP, and then you can start to extract information that is useful for you. By the way, spaCy.io, that's the website of spaCy. So let me just run this cell. And here you can see what the output is. So we read in the language model. This language model, we feed it the sentence that we want to analyze. And then we write that under the variable doc. And then we can start to inspect the contents of this doc object. And here I'm using list comprehension for those of you who are not familiar with this type of syntax. It's basically a for loop that loops through all the different elements that are in the sentence, that are in the doc objects. But it's an easy way of notation. So for every token, for every word, so to say, that's within this doc object, I'm printing its text. So you can see that over here. It's great that you are joining this workshop, exclamation mark. It's part of speech tag, it's lemma, and it's dep, dependency. So here you have the text, part of speech tag, so so it's for pronoun. Lemma, this one is empty, and then dependency, so this is the subject of the sentence. Nice thing is lemma. So remember I mentioned lemmatize. Oftentimes when we use language, English is not that difficult in terms of grammar, but still, I walk, but you walk, he walks, and suddenly there's an S. So in the past tense, I walked, we have been walking. So this single verb, walk, can get a lot of different verb endings. And in English, this is really just a quite simple system, but there's a lot of languages out there that can have a very extensive list of different verb forms, or very extensive list of different forms in which a noun can appear. So here I have a table, and if there's 2, there's tables, so you have a plural, but especially if you have case in your language, or there's a whole bunch of variants of this same concept. And what the lemmatizer does, it takes the lemma of the word, or the dictionary form. So if you were to look up the word walking in a dictionary, you would look under walk. If you were to look up the word tables, you would go to table, etc. And that takes the lemma out of the text for you. And that's especially useful once you start to normalize your texts and start to prepare them for some machine learning.
We have one question in the chat regarding the part of speech tag, whether that's universal across all languages. So for verb, if that verb VRB is the same across English and Dutch and different languages.
Yeah, as far as I know, they use the same set of abbreviations for parts of speech tags. However, thinking about all the diversity in languages, it might not be a tag set that is universally applicable to all types of languages. So that you might run into some problems if you are looking into some languages that have not been coded frequently or that have not been studied extensively, then you might run into problems with this part of speech tagging, and then you might find that it's missing a category or that some things are mislabeled. But as far as I know, they use a universal tag set to tag the words. Yeah. And here's also some links to the website of spaCy where you can find more information on these tokens. And part of speech tags and different things you can do and different information you can take out of this doc object. We'll just dive into two nice things you can get out of this doc object. Here you already saw a list of different items, but you can actually do some really cool things with it. What you can do, you can start to explore how the words in a sentence are related to each other. And you can actually visualize that. You can make a syntactic tree or dependency tree visible in a presentation in your notebooks. And it could be sometimes really nice to show to a client. It could be really nice for yourself to start to explore how a text is built up. And also the syntax here is quite easy. And the big player behind this, the big engine behind visualization of spaCy objects is spaCy. What you basically need, you need some text that you run through this NLP function, create a doc object, and then you can say spaCy, spaCy, render it for me. You give it a doc object. You say, I want to have a dependency parse of this sentence. And because we're in a Jupyter notebook, you just have to specify that Jupyter is true. Otherwise, you probably just get some HTML code instead of a nice visualization. If we run this cell, then suddenly you get this very nice visualization with a lot of arrows. And here you see the sentence. It's great that you're joining this workshop. You get the parts of speech tags behind it. And the nice thing is, the arrows show you how the words are related to each other. So here you can see this workshop. You see that this and workshop are related because this is the determiner that belongs to the workshop. Joining is a verb, and here you can see that the direct objective to join is the workshop, etc. So it helps you to explore the syntactic structure of your sentences. And then on to named entity recognition. We have some questions, I see. So with regards to a lemma, what if I want to identify topics in a text? So I would like to combine words based on their meaning. For example, auto and car should be into the same box. How should I handle it? That's a nice question. We'll get to some topic extraction in a bit in a notebook. And there you will get some idea on how to do that. And if afterwards it's not so clear yet, then let's get in touch by email, and I can explain it a bit further to you, because I see the time is flying. Yeah, you're welcome. So just show you what these named entities are. And remember, sometimes it's useful to know if, for example, you have a big set of documents and your client or customer or stakeholder wants to know maybe which persons are mentioned in these texts, or what geographic locations are mentioned, and maybe how they relate to each other. Then a named entity recognition is one of the very first steps that you take. So if we just go back to this paragraph number 1, there where we have this is the very first paragraph of a Sherlock Holmes story. What we can do with it, we can start to find the entities that are present in this text. Now we use spaCy for that. So again, we use the NLP function. We feed it the paragraph. So here you can see you don't even have to tokenize the paragraph into sentences. spaCy just does it for you automatically. So you create a doc objects. And then here again, with these square brackets, you can see it's again something we call a list comprehension. Again, it's a for loop, but then condensed a bit. So we take all the entities out of the documents. And for each document entity, we print the text itself. And we also print its label. Now, if you do that, you start to see this. So first of all, it extracts the combination of words, the year of 1878, and it assigns it the named entity label, date. So it correctly identified this string of words as a date. So that's really interesting that it can do that. The University of London is recognized as an organization. Netley is a person. Army is an organization. Fifth is an ordinal. So there you can see that it's a really powerful technique to extract these entities. And by using something like this, or using this comprehension, or like the elements that you can see here, you can, for example, for a certain use case, start to extract from a text all the persons. Write them up in a list, maybe print them somewhere, maybe list them, maybe count them, but those can be very useful things in a lot of use cases. And of course, there's also a very nice way to visualize that using spaCy. So again, you use spaCy.displacy.render. Just give it to me on the screen in a Jupyter notebook. And instead of style is dependency, here we say style is ent or entity. And this always works really well if you try to present your text mining results or the possibilities, but also the limitations of an automatic language model that extracts entities from a text. So here you see in nice highlights the dates, the organizations. Also note that the same categories have the same color. India, for example, is a geopolitical entity. Again, the spaCy website tells you what all the abbreviations stand for. So Afghan here, so this is a, I think it was a national or religious party, if I remember correctly, the abbreviation. Bombay, the geopolitical entity. So it's pretty good at getting the entities out, but it also makes mistakes. So here Kandahar is seen as a person. And of course, Kandahar in this context is not a person, it's a city. So it's been misclassified. So you also see that the automatic language model is not able to do everything perfectly. It will make mistakes, it will have inconsistencies, also depending on the language that you're using and how far the development of the different models is in your specific language, the performance of your named entity recognition might differ a bit. In general, the Chinese and English language have been very well studied and have great parses, etc. And then as soon as you go to other languages, the performance drops a bit. But the nice thing is, so here you have all these different entities, but it's also possible in spaCy, goes a bit too far for this workshop, but it's also possible to define your own set of entities. So imagine you're a researcher that wants to look into possible medicine for COVID. Now you're interested in a vaccine. It might be very nice if you're able to extract all entities that have to do with medicine. So you have a separate label, medicine. And then you can actually teach spaCy to start to recognize things that relate to medicines and assign it their own label. That's for outside of the workshop, but if you're interested, let me know and I can point you to the right resources for that. Let me have an eye on the chats. Yeah, that's a very good question. Let's see, when can we use NLTK and spaCy, or do we use them together, or can they do the same thing? So basically, I mostly use NLTK just for tokenizing my sentences because it's fast. And I use spaCy for almost everything else. So I like to use the combination. The spaCy library itself is basically enough to do most of the tasks for you when it comes to analyzing and pre-processing your texts. NLTK is a bit more limited in its functionalities, although it does have a named entity recognizer. It can do part of speech tagging for you, but it's oftentimes a bit more complex to use it, or not as handy. Might also have to do with my habits, but if you want to invest time in a solid NLP library, then spaCy is a very good place to start. And NLTK, if you just use word tokenize and send tokenize, you can get really far already. And there's another question about entity recognition. What if the entity, like the city or person, comes without the uppercase? Does it recognize it too? And that's a very good question. And indeed, this is one of the problems that you might find when using entity recognition. When you leave out the capital letters, you're leaving out a very distinctive feature of what makes a person name or a city name a city name. That's basically one of the discriminative items that most entity recognizers use to identify their entities. If you take out the capital letters, you decrease basically the how do you say, you decrease the chances that it will do it correctly. So we can, for example, just put in a text to try it out. Let's say I live in I went to Amsterdam. Oh, there we already go. It thinks it's an organization. Let's see if I say London. GPE, so that's a geopolitical entity. So if I say I went to London, and if I feed that to our spaCy model, then it will recognize it as a city. If I feed it with a lowercase letter, it still recognizes it. Okay. Let's see what it does with Amsterdam. If I don't use a capital letter, it will probably just crash. It doesn't find any entities at all. If I give it a capital letter, it misclassifies it, but at least it thinks it's an entity. So yeah, to answer your question, it makes a big difference. You always see that people tend to take out the capital letters from their text as a standard pre-processing step. But if you want to extract your entities, don't take out the capital letters. Only normalize capital letters at the start of your sentence, because there, of course, your capital letters are not always relevant or useful. But that will definitely improve the performance of that model. And if you look at the newest deep learning models, they tend to come in two variants. A variant uncased, so that's basically trained on a corpus with all lowercase words, and cased. And those models have been trained on a corpus where the capital letters are kept. So it gives a lot more variation, gives a lot more different words, because you also have the start of sentences and names written in capital letters. But those are the models that you need if you want to do any named entity recognition. So yeah, that's a very good point. Yeah, and talking about transformers, I'm just quickly going to run it. I am already on a GPU right now. I think if you go to tools, no, let's see. Yeah, I'll put it in the comments of the notebook. But in Colab, you can actually define what type of computing power you want to have. We're now gonna just going to quickly show you how to use one of those fancy new transformer models, or a model based on deep learning technologies. And these deep learning technologies, they just want to have, they're very data hungry, take a lot of time to do inferencing, and without a GPU, they become super slow. So if you run this, make sure to use a GPU, and I'll add some comments here in the notebook how to do that in Colab. So here, first we're gonna install the transformers library, and the transformers library has all these deep learning models for NLP in it. So this is also a useful way. So the Colab comes with some packages pre-installed, but sometimes you need to install a new one. And the way to do that, instead of having to go to your terminal and download something using pip, you can actually do that inside the notebook itself by using !pip and then just the normal syntax. So here I am installing the transformers library, which is not automatically part of the Colab environment. I'm seeing some questions in the chats. Yeah, nice, Wumika. Thanks for the suggestion. Yeah, especially if you really want to make sure that your specific language is boosted or performing better. A lot of open source projects going on in which you can contribute. Definitely do that. So, and here, this is really nice. Transformers has something called pipelines, and there you can do some off-the-shelf inferencing using deep learning. So models that are very powerful. And here we're using a pipeline. So instead of NLP or etc., we define an NLP objects by running pipeline and saying we need NER, we need a named entity recognizer. And we're giving it a paragraph number 1, so the text with Sherlock Holmes in it. So see here, it's downloading a lot, and even from looking into all these downloads and the time it takes to get it in, you already realize that these deep learning models are quite big. And then we can print our NLP sequence. And there you see here that the word university got a certain score and is connected to the entity organization, and this score tells you how confident the model was that that university is indeed an entity. I'm asking here the question, is there something that stands out? For now, we're running out of time, but just quickly to show you something interesting. It's also tokenizing not just the words for you, but sometimes even parts of words. And that makes these types of models very powerful. Sometimes you have a very uncommon word or very rare word, and breaking it up into little pieces, these deep learning models can still kind of understand what this new or uncommon word means. More on that, if you're interested, let me know. I can send you some references. Yep, it's already 52, time is flying. Yeah, I'll go through, just wanted to show you very quickly some machine learning. I think it's important for you to also see what you normally do if you prepare a NLP text or use NLP to prepare a text for machine learning. I'll go through it a bit quick, try to do it within 1 minute, and then you can go through the notebook yourself. There's some documentation in here. So first of all, I am reading in some data. Make sure that it's inside a data frame. You can check the code for yourself later on. We can start to explore the data frame, see what it looks like, and indeed you see here a lot of texts. Well, there I say start to explore the text, but you can try that at home. And one of the nice things is I'm installing again a helper, a package that can visualize different topics inside of a text. So this will take some time. I'm just going to skip it. Try it at home and see what it does for you. It's going to be interesting. There was a keyboard interrupt. Don't worry, it should work on your own machine. But the problem is, as soon as you start to feed just the text into these models, then words like the and he and is, they're going to stand out because they occur so frequently. So, and we also have all the punctuation going on. So basically what we normally do, we start to normalize the text in such a way that all these frequent words are taken out. We take out the punctuation. So this first paragraph, oh, we have error here, but if you take out the punctuation from this text, you can imagine it looks a bit differently. And then we can also take out all the common words. So words that don't carry a lot of information. I'm getting a lot of error messages. Sorry guys, I should check that. But basically what it will do, it will take out words like in and the and of, etc. So you won't be disturbed by that. And I've put this all in some nice functions in here. You can check them out later. Let's see the chats. Yeah, score is the confidence, sorry. So here are some helper functions that help you to pre-process a text, so to make sure that all the nice elements that are not very helpful in classifying or in any machine learning algorithm, kind of noisy data, they're filtered out. You can apply that on your data frame. And here we will see some progress bar running. We're getting a lot of, it's probably the punkts. So let's see if we just print the first text. There you see it's full of noise normally, and this is very typical for natural language. Double question marks, here's a new line character. So you need to filter out all these things from your texts. And then here's some code that helps you to transform the text into digits. So after you clean this text and you take out all of this noise and you normalize the words, so you take out the past tense, you take out plurals, then you can start to transform them, translate them, so to say, into a numeric representation. Here's the code to do that. I don't have time, unfortunately, to go into it, but definitely check it out. And if you have any questions, there's some explanations here. Do let me know. But basically, it will transform your text into some digits. And those digits, you can start to feed into a machine learning algorithm. Besides the TF-IDF features, you can also use these word embeddings. So remember, those were vectors out of a deep learning, out of a neural network. And here it's downloading. Let me quickly say the chats. Yeah, there are errors even after the library was installed. Yeah, I should look into it. I didn't have this error yesterday, but Bhumika also noticed it, so I should dive into it and I'll fix it, and I'll let you know as soon as it's fixed. Nice things with these word embeddings. I'll quickly show you just one last thing, and then I'll give the floor to Leonia. So the powerful thing about this word embedding, so recall you can translate words into digits by looking into how often a word is used and how spread out over your whole document set it is. But you can also start to model a word in its context. And if you do that, then somehow this number representation of the word carries within it some notion of the meaning of the word. And you can basically check that out by asking your word embedding model. In this case, it's a glove embedding for the guys who are interested, the girls who are interested, I should say. You can ask the model, what are the most similar words to the word Labrador, for example? And a word embedding model will spit out words that are actually related to the word Labrador. So you get retriever, Newfoundlander, retriever, Scotia, etc. So that's really cool. I'll leave it to here. I'll have some bug fixing to do. Yep, I'll fix the code. I'll do that tonight, so you'll be able to play with it. Time was flying. Thank you so much for your attention. I'm sorry I went a bit over time. I'm sorry there was too much material to cover, but it's just a really cool field. There's a lot of things happening in it. There's a lot of material to cover. So if you're interested in knowing more, if there's some errors within a notebook or you have more questions, do let me know, do contact. And I hope you learned something today. Thank you very much.
Thanks a lot, Saskia. It's okay. You didn't steal our time. It's awesome presentation and awesome workshop. And as everybody mentioned, just as soon as we take a look at it, that will be fixed and we share it with you. On top of it, this video is recorded. So usually within 1-2 weeks after the event, the video will be published, and you can find the link via different channels. It will be in the GitHub Repo, the link to the video. The link to the video will be in Twitter, and the link to the video will be on LinkedIn. So, and also we have our YouTube channel where you can watch this video later and do a workshop again and again and again. Quick thing that I want to share with you. We have awesome news, and the 3rd of February, I asking you to mark this date in your calendar, because at the 3rd of February in 2021, there will be an event. It will be the virtual event before the FOSDEM, and FOSDEM, this is the greatest open source commitment event in the world. So we'll be responsible for leading the Python track for this event. So the 3rd of February, I will be interviewing 2 people. It will be Guido van Rossum, and this is actually the person who creates the Python. And the second person is Sophie van Langedam, and Sophie works for Explosion, and she is at the let's say she is responsible for spaCy. So what I want to say to you, we'll be open our channels to getting questions from you. So if you have any questions that you want to ask for the Guido van Rossum, and if you have any specific NLP questions or related spaCy question that you want to ask Sophie van Langedam, so we'll open our channels for your questions. So please send them, and the best questions, I mean, will be grouped by, transformed, and will be presented and answered within 1 hour by Guido, and then within the other hour with Sophie. So Bhumika, floor is yours.
Thank you so much, Saskia. It was a wonderful workshop. And with that, we're drawing to an end, and I think we're just a little bit over time by 3 minutes. So thank you all so much for joining. And hopefully you learned something and can apply it to your work. You can experiment with it, and yeah, we'll get the notebook with the running code up soon. And yes, also feel free to watch the video recording and follow it at your own pace. So thank you, and have a really good evening, and see you next month.